Algebra 2, Quadratic Transformations. This is Teacher Talk, concept number 6. So what we're going to do is that you're going to describe the transformation of this quadratic function. So thinking in terms of vertex form. So we want to pick out the h and the k value. Remember, the h value is in terms of subtraction. So you think, what value is being subtracted from the x? Well, a positive 7. And then the k value is 1. So that means our vertex of this quadratic is the point 7, 1. The axis of symmetry is the vertical line that goes through the x value of the vertex and has the equation x equals 7. To create the graph, let's start with the vertex. I like to place it in the middle of the table. Then put x values in the negative and the positive direction. Plug in those numbers into the equation one at a time for x to find your y value. And you'll get values at the symmetrical numbers 5, 2, 1, 2, and 5. Now draw your xy axis and label it, and label a scale. And then plot those points, and you should get a U-shaped curve that opens upward. Go ahead and dash your axis of symmetry and see how it's a vertical line where x equals 7. Now for our domain, it's what values we can plug in for x and get real numbers out. Well, we can plug in any real number. Our range is limited though. Only certain y values are used to create the curve. So those are the y values that start at the y value of the vertex, which is 1, and are 1 and all the numbers that are greater than 1. So y will be greater than or equal to 1. Look at number 2. So think about the transformations that are happening, and let's describe those. Well, we have a negative 1/2 for our a value, so that means we're going to have a reflection and a compress by a half. And then our h value is 1, so we're going to have a shift to the right. So our h value is at 1, and nothing's being added or subtracted at the end of this function, so our k value is 0. And now we know our vertex and our axis of symmetry, x equals 1. So we'll just do this process again. We'll plug in 1, 0 into our table, and then x values in the negative and the positive direction. Plug those numbers into your equation one at a time. And so we'll get negative 2, negative 1/2, 0, negative 1/2, and 2. Go ahead and draw your xy axis and label a scale. And then as you plot these points, you're going to get a U-shaped curve that's a little wider than the parent function and opens downward and has an axis of symmetry on the vertical line x equals 1. Our domain will be all real numbers again, and the range will be all the y values that in this case are less than or equal to 0. Now let's just describe the transformation represented by g of x in number 3. So just from the parent quadratic function, g of x equals negative 1/5 x minus 5. So we have an a value of negative 1/5. Since it's negative, that means we have a reflection across the x-axis. Since it's a multiplier and less than 1, it's a compress by that number. So we say compress or a shrink by 1/5. And then our h value is 5, so this is shifting to the right 5. Our vertex is the h and the k value, which is positive 5 and 0. Now try writing a function from the parent quadratic function and then identify the vertex. So you want a vertical shrink by 1/3, a reflection, so that means our multiplier of a needs to be negative and a 1/3. Write 4, so our h value means that we need to shift it, subtract 4, and then up 7, so our k value will be positive 7. Now let's put this into vertex form of a quadratic equation. So y will, or in this case g of x, will equal negative 1/3 times x minus 4, that shifts it to the right, 4 squared, plus 7. And then to identify the vertex, that's the h and the k value. So you think, what value is being subtracted? 4. So our vertex is at positive 4, 7. All right, that concludes our teacher talk on concept 6.